All right, guys. So I will go over what we did yesterday through this activity. Before we get started, this is what you need to know in chapter 4. So you need to know the difference between discrete and continuous random variables. You need to know whether a probability distribution is a probability distribution by checking if each probability is between 0 and 1 and the sum of probabilities equal to 1. You need to know how to find the mean and the standard deviation of the probability distribution, which we did yesterday, and I will demo again today. And you need to know how to find the expected value, which is the same as the mean, as we did yesterday. And you need to know how to work with binomial distribution using two features on the calculator. One is called binomial PDF and the other one is called binomial CDF, and you'll get a chance to experiment with that one more time today. So let me just begin with the question 1 on the expected value. A life insurance company sells $250,000 one-term life insurance policy to a 20-year-old man for $350. According to the National Vital Statistics Report, the probability that the male survives the year is 0.998734. That's a probability that you won't get the money, you'll survive. Compute and interpret the expected value of this policy to the insurance company. So we need the expected value. In order to find the expected value, guys, you need to have the probability distribution table, X and PX. Well, you pay 350 to buy the insurance. So what do you think? I'm going to list the 350 as a plus or a minus, the gain here. So X is the amount that you gain. What would it be for the 350?
We work on the company side, so it would be a gain.
Oh, no, it's you. That's the expected value of this policy to the insurance company. It's you're paying the money and you're gaining the money.
Oh, okay.
So it is going to
So
be
it's plus.
negative 300.
Oh, negative.
350. Just like what we did yesterday, when you bought the ticket, $2, it's a negative $2. And what is your chance of losing your money? Well, actually, it has to be a very high chance, which is a 0.99873.4. Definitely, we buy a term life and we hope that we'll never have to use it, because if we end up using it, that means we're gone from this world. So that's the chance that the 20-year-old male will not get, just this insurance is very high. It's 0.998734.
Mr. Bazzi?
Yes.
I think what Marwa was saying is it says compute and interpret the expected value of the policy to the insurance company. So are we changing the problem to be to the
Oh, no, but no, that's I see what her interpretation. No, it's just the because you're the one who initiated the action. You're just buying the insurance. It's the consumer. It's a 20-year-old male. I know the wording probably may lead you to think that way, but it is from the eyes, just of the person, just who's buying the insurance. But you know what? The only thing will change, the interpretation is going to be very much the same at the very end. It's a loss, just to the person who's buying it, but it will be a gain, to the other person who's getting the money.
Yeah, that's true, because I was looking for this last sentence where it says.
Yeah, it doesn't matter, actually. For example, if I say I'm 5 years older than you, you can say you're 5 years younger than me. It will be very much the same statement at the end.
Yeah, okay.
Yeah. And now, if you end up getting the money, that means the person did not make it, just to the end of the year. How much money will the family get? Not the person gets, it's the family. It's at 250,000, but how much the gain would be? You already paid 350.
249 and 650.
Yeah. $249,650. And you guys understand why, because if it is a gain, we're subtracting the 350 that have been paid already. What would be the probability of getting this money? Well, you know, guys, that the sum of probabilities must equal to 1. So what I'm gonna do, guys, watch. I'm gonna just take 1 and minus 0.998734. It will be 0.001266. And now the expected value, guys, which is the same as the mean, which is the sum of x px, it will be negative 350 times 0.998734 plus 249,650 times 0.001266. Let's do the math. Next one. This is very, very similar to what you have on the assignment. According to the American Lung Association, 77% of adult smokers started smoking before turning 21 years old. 10 smokers. So 77%, guys, is the probability of success. P is 0.77. What's N here? 10 smokers, so N is 10, are randomly selected. And the number of smokers who started smoking before 21 is recorded. Explain why this is a binomial experiment. Well, the probability of success is 77%. That doesn't change from one smoker to another. He didn't say it changes. Fixed number of trials, which is we have 10. So we're interviewing, surveying only 10 people. And the probability of success will be the same, you know, just from one person to another. It's 77%. So it is a binomial experiment. Once you can identify one probability of success and one fixed number of trials, guys, your experiment is binomial. Use your TI-84 to find the probability that exactly 8 of them started smoking before 21 years old. So he wants a probability of X equals 8. You still remember the feature? It's binomial PDF. And you put NPX. Let me just write it down so you know what I'm doing. N, guys, here is 10. P is 0.77. And X is the one in the question, which is 8. And here's how you do it on the calculator. Second, variables. And actually, when you go to the assignment later, you're going to see a short video, 15-minute video, just 10-minute video pertaining, you know, just to using binomial PDF and CDF. So you'll see that. So we have 10, we have 0.77, and the X value, guys, is 8. And here you go, 0.2942. Next question. Use your TI calculator to find the probability that at most 8 of them. Can you guys remind me what the sign of at most is? How do I write this? At most, guys, is this sign. At least, let me just write them down for you, this sign. Less than, it's this. More than, that one. And let me put the at most at top here. So this is at most. And remember what I said about at most. It's binomial CDF for at most. And you put N, which is 10, 0.77, and then 8. It's going to be a lot larger than this one, because at most 8 means 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. So it's going to add all of them. That's why we're using CDF, not PDF. 10, 0.77, X value is 8. See, 0.7079. I'm rounding to 4 decimal places. Use your TI-84 to find the probability that at least 5 of them. At least is like this, guys. Okay. Look, when it is a greater or greater than or equal to, it has to be 1 minus the CDF.
Can you pull the paper up?
Yes. There you go.
Thank you.
Okay. Here's how you figure it out, guys. So look, for greater than or at least, you have to do 1 minus binomial CDF, but you put the n, which is 10, you put the p, which is 0.77, and then greater than or equal to 5 means, guys, 5 or 6 or 7 or 8 or 9 or 10. So what was not included there from the entire, just set of values? So we want it from 5 and up. Here you put the complement. So what comes right before 5, guys?
4.
4. You put the 4 here. And I put the rules yesterday for this. Look, guys, right here. Probability of X at least A, which is here at least 5. Look what you do. 1 minus binom CDF NP, and then you do A minus 1, 5 minus 1, which is 4. And that's what I exactly did here. So you guys, you do this. Second and variables. You put 10, 0.6, and just do the 4 here. So I got 0.0130. So it's 1 minus 0.0130, and you just subtract 986. So there will be 0. So you get 0.9870. Use your TI-84 to find the probability that more than 5. Again, guys, it has to be 1 minus binom CDF. 10, 0.77. Okay, more than 5 means what? What's more than 5? More than 5, guys, means 6 or 7 or 8 or 9 or 10. Since we're doing a 1 minus, we're doing the complement. So what should be the number right here? What's the number that comes immediately before 6? It will be what? 5.
5.
Yeah, and this, look, guys, I just did it right here. X more than 5. Just follow this. More than 5 means 1 minus binomial CDF MP5. When it is at least 5, you have to do 5 minus 1. Here is just 5. And let me do it. Second, distribute. I'll just change this to 5. I got 0.056, 0.0569. Which is 9431. And finally, probability of less than 5. So I'm putting all the options, guys. Less than 5, guys, means at most 4. So you can use the CDF directly. It means less than 5 means 4 or 3 or 2 or 1 or 0. So it's at most 4. And at most 4, we know already it's binomial CDF. And then you put 10, you put 0.77, and then you put 4, and then you compute the answer. And the final question is find the mean and the standard deviation of the binomial distribution. The mean, guys, I will provide you with the formula is n times p. N you already have it is 10, and P is 0.77, and you just multiply it 7.7. And the standard deviation is square root of NPQ, which is 10 times 0.77. And Q, guys, it's 1 minus P. And don't forget the square root. And that should be 7.7 times 1.33. If he asks you to find the variance, you just do N times P times Q without the square root. But he doesn't want the variance. He says the standard deviation. So this is very much it, what we did in chapter 4. And just to show you the assignment, very easy now. It should be very easy assignment after what I did here. So state whether the variable is discrete or continuous, 1 and 2. Number 3, find the probability of selecting a household that has less than 2 cars. Less than 2 cars means what, guys? Less than 2 cars. These are the number of cars and these are number of households. How do you interpret less than 2 cars as what?
The probability of 0 and 1.
Yeah, probability of 0 or 1. Just add them. So less than 2, guys, means 1 car or no cars. So you just do these two totals, add them up and divide by the grand total. You need the grand total, which I already give it to you. It's 1,000. All right. State whether this is a probability distribution. Remember, guys, in order for this to be a probability distribution, each probability must be between 0 and 1. If this is violated, you stop. You don't need to verify the second one. And the sum of all probabilities must equal to 1. Both conditions must be met. If they're not met, then it's not a probability distribution. Find the mean and the standard deviation of this probability distribution. I'm going to show you how to do this by hand one more time, guys, so you don't have to do not by hand, using calculator, so you don't have to do it by hand. Okay, here you go. I'm not going to do the actual example, but I'm just going to show you a similar one. Let's suppose these are the x values in L1 and these are the p of x values in L2. Here's how you do it, guys, by using calculator. You go to stat, calc, one variable statistics. You put the x values in L1 and the frequency, which is the probability in L2, and you hit calculate. X bar is the mean and sigma is the standard deviation. So all you have to do, guys, for this question is, instead of what I did here, just put the L1s and the L2s. And the last one, which is very similar to what I just did. A recent survey found that 72% of all adults over 50 wear glasses for driving in a random sample of 9. So this is a P and this is N. What is the probability that exactly 6 of them wear glasses? So you need to find the probability of x equals 8, which is a binomial PDF, as you know. What is the probability that at most 5 of them? You know, at most means binomial CDF directly. So that's what you need to do here, which we did. Probability
What
at
is the
least.
probability x equals 6
What is it?
for A? X equals 6.
Oh, 6 of them, you're correct. And here you need the probability of x less than or equal to 5. The probability that at least 6 of them, guys, just follow this. I did an at least here. When we did 5, we did 1 minus 4. When you do 6, you do 1 minus 5. 1 minus binomial CDF, and x will be 5. What is the probability that none of them wear glasses? What would that be, guys? Probability of what?
0.
X equals 0. It will be PDF, no CDF. The CDF, guys, is only used with inequalities. With equal, it's PDF. And what's the mean? Here's the formula for the mean, NP. And what's the standard deviation? So I would say that shouldn't take even half an hour to do, just probably less than 20 minutes. You can get this active
I'm
assignment.
sorry, just for the question number 5.
Mm-hmm.
Is the mean would be the X bar, the first one, or the second one?
Yes,
The
yes.
sum.
So X bar. Using TI 84, mean is X bar. But we call it this in the chapter, but it is X bar.
Oh, okay, because yesterday we used the sum one, the second one, or no?
No, you don't use it. Not the second, not the third. Only we use X bar and we use sigma. That's all we do.
Oh, okay.
That's it. Good
Thank you.
question. All right.